Hello everyone, today we're going to solve one more interesting problem which is container with most water. This is a medium level question and this is the last problem in the two pointer pattern. So without wasting much time, let's jump into the problem statement. And one more request, please take pen and paper and solve it with me. Now just imagine, I'm going to tell the problem statement and you can just imagine on your brain, and obviously at the end you can understand what the question asks you to do or what the problem asks you to do. Just imagine there's a city, and in that city we have building one next to another. So that's what the given input. Assume there's a city X and they give list of building which is stack upon one after the another. And with the height, so this is the height of first building and this is going to be height of second building. Okay, just assume like that. So at the first place there is a height of 1, and at the second place we have building height of 8, like that. N building is stack upon one after another, or n building was built one after another. Now there's a raining. Okay, there's a rain in the city. Now what will happen when rain gets, the entire thing will get filled up, am I right? So like that here also entire thing will get filled up. If I want to do some drawing, it will be like this. So entire area will be filled with water. Now your task is to find the maximum area where you can get most water. For example, in this example, the maximum area you can get is 49. You can ask me how. For that, you can pick this particular area. So this will give you the maximum water for this particular problem. We can see later on why this is the answer. So you guys understand what the problem really asks you to do to get the maximum area where you can get the most water out of it. Okay, so now without wasting much time, let's jump into the brute force solution. So brute force is very simple. What you can do is we can start one pointer from this space and we can have another pointer here which will just keep on moving it. So at every single position we'll just compute the maximum area of water we can pick. So now let's see what is the formula for it. So this formula is going to be used throughout the solution, even in the optimal one. So listen carefully this particular area. And this is the formula to calculate the area. If you remember, this is the formula for area of rectangle. The same formula we're going to use because this is a rectangle, isn't it? If you take this or if you take any place, this just look like rectangle. So to get the area, we can use height into width. You can ask me how can I get the height? That is very simple. Height is going to be minimum of this pointer, either this or this. So nums of P1 or nums of P2. And this is going to be height, and width is pretty simple. So P2 minus P1. This will give you the width. Let's say P2 is here. And what is the width right now? Width is going to be 6 minus 1. The width is going to be 5. And you can ask me what is the height? Height is going to be minimum of 1 comma 4, which is the minimum 1. So the entire water you can store is 1 into 5, which is 5 liter. You can ask me like why should I pick the 1? If you think hypothetically how much water you can store if the building height is 1. How much water you can store if the building height is 1? If you think hypothetically, you can store only up to 1 level. Am I right? Because even though if rain is keep on coming, the water can be filled only up to this level if you take this building as a starting point. Am I right? If this is starting point, you can store up to this level of water only. And why cannot we can store this level? Why can't we store is, even though if it's rain, the water will get overflow. Am I right? The maximum height is this. And if even though if keep on getting rain, this water will get overflowed. Like that, you can start two for loop and compute the area. Now let's jump into the pseudocode. So initially we declare the result as 0 and we'll start the two loops, which is from 0 till the end, and the inner loop will go from I. If you remember, if you're taking this will be our next point. So j will go from I plus 1 till the end. Now we have to compute the area. Am I right? The area formula is minimum height into width. So I guess I don't have space here, so let's move to the next page. Or we can write it here also. Now let's compute the area. So area is going to be minimum of nums of I comma nums of j. Am I right? It's going to be minimum height. Now for width part, width is going to be j minus I as we discussed over here. Now we can check whether it is greater than the existing area or not. For that we can simply write result is going to be max of the current area. So this indicate the current area comma already existing area. So which is greater. If this is greater, this will be replaced with the result. If not, result going to say string. And we can close this loop and we can directly return result. Now, if we talk about the time complexity, it will be of n square and space is going to be of 1 because we are not using any additional storage to compute the result. And for time complexity, this particular loop will take n time. Again, this will take n time. So the overall time complexity is going to be of n square for brute force solution. Now, how can we optimize this? So what will be the better time complexity than this? There are two other better time complexity, which is n log n, and one more will be n. So how your thought process should be like how we can achieve this thing to this level. And if you think about two pointer, you can achieve this particular time complexity. You can directly skip n log n. So you can directly come to O of n squares. How we can do it? Let's see. Now let's talk about the optimal solution. So as we discussed in the beginning, for optimal solution, we are going to use two pointers. And there are multiple variants in the two pointers. So one variant will be, they will keep the two pointer at the same position itself. One will be here, one is left, one is right. In one more variant, what they will do is they will keep in the two extreme ends, the leftmost, rightmost. So there are three variants in two pointers. So one variant is this one. So one pointer will be there, one pointer will be there, and they will start computing the result. So for our particular problem, if you think about which solution will be better, if you think variant will be this one, keeping at the extreme end, because if you keep at the extreme end, our width is already maximized. Am I right? So right now, if you see the width is already maximized. So 9 minus 1, which will be give 8 width. This is the maximum possible width we can get. And in this method, the width is already maximized. So now let's move on how we can optimize the height or how we can maximize the height. That's pretty good question. And we are going to use the same formula for computing the area. So don't forget it. It's going to be minimum height from the between the two pointer and the width, the difference between the two pointer. If you do that, you are going to get the height out of it. Now let's do a quick dry run. So one pointer will be there and one pointer will be here. Now let's do this as first iteration, hashtag 1. Now if you see the minimum height, and if you take minimum of 1 comma 7 multiply with 7 minus 1. So what is the maximum height? It's going to be 6. Am I right? The area is going to be 6. Now let's assume 6 liter because we tell it's a rain. So we assume 6 liter you can get if you take this particular portion. Now we will move the minimum height. So just now I explained a detailed explanation. So now we have confusion like which pointer we should move. So if you guessed it right, that's well and good. We need to move the minimum height pointer. Now which pointer hold the minimum height, which is left. So just move left one position. Now let's compute the area again. So minimum of 8 comma 7 into 9 minus 2, which is going to be 49. I guess this is our answer. Now let's move next position. Now tell me which pointer should I move? The minimum pointer. So just move right because left is going to be 8, right? So minimum value is 7. So just move right one step. Now if I calculate the area, it's going to be minimum of 8 comma 3 into 8 minus 2, which is going to be 6 into 3, 18 liters. Now again, which side we should move? The minimum side. Move the right pointer. Now the height is going to be 8. So now 8 comma 8 into 7 minus 2. The maximum, I mean the minimum height is 8 into 5, which is 40 liters. That's pretty good. Now again, which is minimum side? So in this case, if they both are tie, and you can store maximum this much amount of water. Am I right? Right now you can move any pointer. You can move this one as or else this one. It's your wish. Right now we will move left pointer. So left will move left pointer, and now right now left is 6. The minimum of 6 comma 8 into 3 minus 7. It's going to be 6 into 4, 24 liter. And again, which is the minimum? This is minimum. So move this one. Now again, if you compute the area, it's going to be 6 liter if you compute the area. Now I guess we can stop till this. And when we need to break the loop is when this 2 pointer cross each other. If the 2 pointer cross each other, which means we already seen all the possible areas. So we can cut the loop and we can stop it. We can directly return the result. Right now, if you see which is the maximum result out of this. So 49 result, 49 liter is the maximum area you can get. Am I right? So just return 49. And if we talk about the time complexity, it's going to be O of n. Now let's move to the pseudocode. So initially we'll declare result is going to be 0, and the pointers, if you remember, we are going with variant 1, which is having at the two extreme ends. So left is going to be 0 and right is going to be n minus 1. N in the sense the length of array, minus 1 which will be at the rightmost, and left is at the leftmost. So we can start the while loop, and if you remember the condition, it should be left is less than right. If movement when the both cross each other, we just stop the loop. So the condition is going to be left is less than right, and we'll just compute the area. Area is going to be minimum of nums of left and nums of right. And if you talk about the width is going to be r minus l, which will give you the width. Now you can do the same thing, which is the result is going to be maximum of area or the result itself. If this is max, it will be updated. If not, it will exist the same one. Now if you think about the pointers movement, if nums of left is less than or equal to nums of right, this case, if the pointer both are equal, I mean we find this case here, when the both the points are equal, we can move either side. Right now we are just moving to the left side, so left is going to be plus equal to 1, and else case we just move the right point, right minus 1. At last you can directly return the result. Now let's discuss the time complexity for this problem. Now the time complexity is going to be big O of n, because we are just iterating, or we're just seeing every single item only once, we're not seeing twice. So this while loop will take big O of n time, and if we talk about space, it's going to be constant 1. We are not using any additional data structure to compute the result. So the space is going to be same, but the time which is differ from the brute force one. We just optimized from O of n square to the O of n solution, which is a really good one. And I hope you guys understand this approach. Now let's start coding this up. Now let's declare the result. Initially result is going to be 0, am I right? And we'll have 2 points, which is left and right. Left is going to be at the left extreme, which is 0, and right is going to be at the right extreme, which is length of nums minus 1, which will be at the rightmost ending. Now let's start the while loop. While loop is going to be left is less than right, and as a first step we need to compute the current area. Area is going to be minimum of nums of L, nums of R. This will give you the height. And if you talk about the width, we can take width by right minus left. Very simple, am I right? We just compute the current height. This will be current height. Now we can apply the result. So result is going to be max of the current area or the existing result itself. I did small typo, it should be area, not height. Now, once we update the area, so what is our next step? We need to move the pointers. Am I right? So we need to move the lower pointer. So for that, what we can write is if nums of left is less than or equal to right. Why less than or equal to? We see in a case where 2 8, there will be 2 8, and we just confuse like which side we need to move. So typically we can move any other side. So I choose to move to the left side. That's why we put equal to. And if this is success, I mean if this is true, then we'll move the left pointer one position. If not, we can just move the, if this condition true, we can move left position. If not, we can move the right position. And we can directly return the result. Now let's run this. I hope we didn't do any typos. Yeah, it just passed its case. Now let's submit the code. Fingers crossed. Yeah, now our code passes successfully. It passed all the 65 test case, and the runtime is 100 millisecond. Okay, that's fine, pretty good. And I hope you guys understand this problem, and we'll meet again in one more video. Until then, bye.